I'm David Corrado. I'm going to talk about the Android UI layer that was pattern that was introduced pretty recently, I think within a month, that kind of goes into best practices of how to architecture your app. And this is just one layer of that, which it's probably the most important layer to get right. So also feel free to interrupt me if you have any questions throughout. We can keep this free flowing. It's not a big deal if you have any questions or disagree, want to just banter about something, it's all good. So first question you might have is, what is the definition of a UI layer? And I'm pulling all this stuff from the documentation. Previously I would have just thought of the UI layer as strictly the UI. So the fragment activity or the compose code, but actually they define it as the UI and the view model. So their premise of this is it's normally for handling the business logic of a particular user event. Actually, from reviewing the docs, I don't think this line's correct, because you actually in the UI layer it says you shouldn't have any business logic. So I guess some of their docs are inconsistent, but I'll go through that in a minute. UI layer. So the UI layer has UI elements, which are directly bound to stakeholders that will directly update the UI elements. And then there's two additional layers that I'm not going to cover. One is the domain layer, which they say that's where the business logic should lie, not in the UI layer. And then there's the data layer, which is for like retrieving stuff from a remote or local layer. So this slide kind of goes through the evolution of how Android over time has gone through to how to build your UI. It's not specifically related to this talk, but it's useful to have that context. So previously, every screen was an activity, which is the original Android 1.0 way of doing things. Eventually, over time, things sort of evolve into single activity with multiple fragments because activities are heavy. There's less things you can do between transitions, between activities. So basically we lean it on multiple fragments. And then after that, we started getting into compose. So the recommendation of transitioning to compose is single activity, multiple fragments with composable functions. And then the final best case scenario is single activity with composable functions. And that's, there's some risk you have with going directly to composable functions, like it makes certain things a little bit more difficult. Let's say if you had to launch another app or embed another app within your app, it might be a little bit more difficult to deal with living in a pure compose world. So we're going to be a little slow at my work about transitioning to pure single activity with composable functions, but that is the best practice that we'll see once I get there, whether I completely agree to transition to that part, or make sure, or basically wait till I think Android's ready for us to do that. So the next thing that I'm going to talk about is UI state. So generally, this is a data class, like it's kind of laid out here at the bottom. It represents the UI. So it's supposed to be immutable. So everything in here is a var, a val, which means it's immutable. It only changes in the view model. So this UI state should never get updated in the UI. So never in the fragments or in the composable code. It should always call to the view model. And then you should only consume elements when it's visible in the UI. So like, let's say, for example, you're showing a toast message which is this array of user messages. You should only consume, which means, so like, let's say you get a list of error messages. You show the toast of that list of error messages. And then after you finish showing that toast, you will actually change the user messages list to an empty list. So it basically is a way of consuming that data, but you should only do it when it's visible, because you don't want to consume it when like you're rotating and lose that data and never actually show that to the user, because that's kind of defeats the purpose. So UI elements plus UI state equals UI. So the UI state is actually directly bound to the UI through observables and automatically get directly represented. And I'll actually have some slides that kind of go into more depth there. So what is a UI event? So UI events in this situation are more like one-time events. So they're handled in the UI layer. So usually the user interacts with the UI and an event gets fired off to the view model, or actually there's a tree that I'll go through that determines how you actually handle this UI event. And then, yeah, there's more details of this. There's I think, yeah, on this next slide, it actually has the decision tree. So this is directly from the docs. So, so the first question you need to ask for a UI event is, where did the event originate? So if you actually, the event originated in the view model, the only way you can get the UI to update is actually to update the UI state. If the event originated in the UI, so the user clicked on a button and then what you did is you need to show a toast message or something like that, you'll go to the next chain, which is the event requires business logic. So if the event requires business logic, like does an API or whatever, you're going to actually call a method on the view model, which actually will update the UI state, because once you go to the view model, the only way to go back is actually updating the UI state. And then if the event actually only updates UI, so like let's say it directly only shows a toast message, you actually just show that toast message directly, because you already know that they interacted with the UI. So you could actually just show the toast message right away and never need to update any sort of UI state. So Android is pushing with this new pattern and the new documentation is a unidirectional flow. So the state flows down and the events flow up. So right when you create the UI elements, it's actually bound to the state. So that's what these dotted lines means. It's indirect. And then, so like when your UI elements, when somebody interacts with that, it'll actually fire off an event to the view model, which will sometimes call a suspend function to the data layer. That data layer returns back some like application data. And then that application data inside the view model gets mutated to a UI state that represents something directly in the UI that's something directly in the UI. So for example, showing an error message, showing the actual success state, whatever. Here's another diagram that's in the docs. The use case that you're actually going through here is actually bookmarking an article. I'm in a meeting. Talk to you in a minute. Go downstairs, Benson. So in this example is actually showing, so the page is a bookmark. So what you do is when your page loads and you get the article data, the first step is to bind the UI state to the UI elements. So that's why it's step one. So then the user will click on a bookmark button. That will fire a bookmark event, which is step two here. Then that goes back to the view model. So what it would do is say, add bookmark, goes back to the view model. The view model would actually, let's say, call a suspend function that will say, hey, actually add that bookmark to the server layer, or maybe cache it, whatever way we kind of want to do there. The data layer returns back, hey, success, it actually bookmarked it. That's step 5. And then you mutate that to a Boolean in the UI state that says is bookmarked equals true, and then that would go back. That would actually go back to the new UI state, so that would actually show it as actually being checked at that point in time. State hoisting isn't necessarily specifically related to this, but it's something to keep in mind is when you have a screen and a composable function like this, hello content is a composable function, you should receive state and you should emit an event from hello content. The hello content should not directly be updating the state or anything like that. And you should be hoisting that to as high level as possible to reduce, to make your hello content more testable. And I think that's the main reason there. This is an example of how to consume UI events. So this is like for a short-term event. In specific, this example is a snack bar. So what you would do is somebody somewhere in the view would actually call refresh news, this function off to the left inside the view model. That view model in this specific situation is going to be getting error messages from the server, or actually error messages based off of no internet connection. And then it's going to update that into the UI state. So the screen is actually observing on the UI state. And these are temporary messages we want to show the user. We don't want to show it every single time they rotate or every single time the process gets restarted. So what we're going to do is we're going to show the snack bar inside of here. And then we're immediately going to call back to the view model to say, hey, actually update that this message was shown to the user. And then what that does is go back to the view model. The view model actually updates the state and removes that message to say that this state was actually shown to the user. So this is the way of consuming one-time events, because traditionally there's different ways of doing that in Android. So essentially everything, even one-time events or temporary state, it gets represented in the global, I mean not the global, but the page or the view's UI state. This slide is not as important. I just copied it just to keep in mind that there's a couple different kinds of business logic. One is types of logic. One is business logic, which involves some sort of business logic that actually needs to go back to the from the view model to the domain layer to do whatever business logic there is there. And then there's also UI behavior logic, which is how to display the screen, which gets represented in the UI state. In specific, I basically pulled this from the documentation. They say that UI there should not be, you should avoid using things like context in this view model because it kind of ties you to the Android OS. State observables, how they kind of evolved over time in Android. You can technically really use all of these. I just specifically threw out this slide just because there's other ways of suggesting of how to fix this, how to fix state single events happen in Android. And there's actually stuff in the docs that specifically calls out why you should not do stuff in certain ways. But historically, apps use RxJava for state observables, and then they kind of evolved to live data. But then the problem is live data doesn't support single events correctly. So there's this concept inside of live data called single live events. So that kind of has an ability to consume that single live event. And that kind of pattern kind of is clunky. So what happened over time was a state and a shared flow, which is the coroutine way of doing it. And then if you look at examples of how to do that purely in Compose, there's a Kotlin channel that you can use to observe for UI events. And there's just something specifically in the docs that recommend says why you shouldn't do that. I think it's because they felt it was clunky. They have some things in their docs. And then the last most current way to do it is state, which I put Compose around it because it just seems like such a generic name. But Compose just uses a state object, mutable state, which you can use directly. And this is what you would probably use if you're following the best practices in this doc. So I just wrote some random notes I kind of aggregated based off of me reading the docs, that specifically some things that I think we should do at my job, and I think other people should consider. Some things are, it's actually technically bad practice to expose suspend functions from the VM. So if you expose suspend functions from your VM to your UI, that's actually bad practice. There's a link to the docs of why. A quick synopsis of why that's a problem is because if you expose a send function from your VM to your view, essentially your lifecycle of your view affects this suspend function that you're calling in your VM. So it doesn't persist rotation or process death. There's problems there. So they specifically recommend not do that. Also, if you're adopting this pattern, there's naming conventions in all these docs, which is nice. So you should probably review those naming conventions in the reference docs. Another thing that I actually kind of ran into recently, which is kind of interesting, is recycler views actually don't restore their own state on rotation. So what they recommend on how to solve that is to expose a UI state to the adapter. Don't expose view models, because you don't want to tie your adapter to your view model, and it just kind of is not the best way to share data. So they recommend to expose UI state to the adapter. And then I have a summary slide here. So this is just a summary of everything you learned here. Feel free to ask me any questions, but UI state is built there to represent. UI state is there to represent UI. It's recommended to use MVVM with unidirectional flow. It's actually basically forces you to not do MVI or Redux. UI state should be bound directly to the UI, so then it's immediately reflected. So that is required if you're going to do unidirectional flow, because there's the observing that's happening there, and you're not communicating the incorrect ways. UI state should not be updated in the UI, but in the view model, and it should be immutable, and it should be only consumed when it's visible. When you're doing UI events, make sure you build the decision tree on how you should handle that. UI state should only be consumed for transient. UI state should be consumed for transient state. So just make sure you're resetting the states back to the previous state. So on rotation, you don't show that snack bar again. And business logic should not be in the UI layer. That's really what I got. Any kind of questions anybody has?
I have a question. Do you like the UI state the way they implemented it? And what is the equivalent to iOS for UI state? And do you have a preference between iOS and Android for this particular, functionality they're trying to accomplish?
UI, like, this is a new pattern that Android over time has evolved to, and I think it's almost necessary to persist past process death, because there's a lot of situations where you accidentally consume the state before it gets represented in the UI. So you almost have to follow this pattern to do it correctly, I would say, or I guess you could do this similar things in Redux, but you do need to have a single solitary state. And there's just a lot of different ways that people do architecture in, mobile apps in general. Android chooses to be very, very opinionated and does that with good reasoning. So I would say you have to have a strong reason to go against what they're suggesting, at least on Android.
So it sounds like you like it. How about the equivalent for iOS? Is that, equally, or do you think they need to fix something?
Well, on iOS, there's not really specific architectures that they have to follow. So it's kind of every single app has a different architecture. So like some will be MVP, some will be MVVM, some will be Redux, some won't have any architecture. So Android forces you almost implicitly to have an architecture because of some of the flaws in the way that Android works. Like on iOS, on Android, when you rotate the screen, it actually completely destroys itself. So you have to completely restore it. So iOS doesn't kind of have these problems as much. It's like iOS programming, there's less of a need for like these kind of architectures, but like Zach was showing, his example architecture was Redux, essentially. So it's more of just a way to organize your code. I would definitely recommend some architecture, because if you're not doing some architecture, you're kind of every single page is going to be different, and it's not as easy to hop between page and page. So like some sort of architecture. I think Redux is fine in some aspects, but I don't like it in the aspect of a lot of the time the state's global. So it's kind of I don't know if you know about event buses but like essentially I feel like Redux is essentially event bus, which is in my opinion, an anti-pattern in Android. So like there's probably ways to do Redux correctly, but I feel the way that this is built for Android works really well for Android.
So when I look at this, right, for Android, I feel like it's actually the same architecture as for SwiftUI. If you think about it, minus the magic of the property wrappers. So there's, it's not as automatic maybe as SwiftUI. And it's also the same thing as Google Block for Flutter. They're all sort of the same architecture, right? They're all sort of the view model has your business logic, you perform some kind of mutation on some observed property, and then the view rebuilds itself. The view is a tree of immutable values, and then the rendering system does the diffing and renders the delta as a mutation, right? And they all have this same kind of architecture, I think, which actually makes it easy to move between all of them. But I think all of them have the same kind of problem, which is that they're all incomplete architectures, right? Like there's no dependency injection here. There's no separate navigation element here. So I think they have the same issue.
Yeah, they're both newer like patterns that are still going through growing pains for sure. I would say Android does a way better job of telling you what to do and making it so there's libraries to do what you want to do. So like there's libraries for navigation, there's libraries for like and very opinionated ways of doing things. So once you got to get into the weeds, you'll notice that like all Android engineers are kind of for the most part on the same page of how to build an app. But iOS, you're gonna have to get into a fight with every new company you work with, probably. But then it gets to the point is then it gets to the point of not only do we agree on Android to do MVVM, but then there's some people who want to do clean on top of MVVM, which that's still an argument that still lives there, but yeah. But I think both platforms kind of have different things that they're they're similar in some ways, but Android kind of made this choice for a specific reason, which makes lots of sense. Any other questions?
How's the testing capability of it? Do they go into that, or is that still kind of a future thought?
No, they built this with testing in mind. So like what they want you to do is test every layer in isolation. So like the UI layer you would test, and then you would test the domain layer in isolation. Then you would test the data layer. Like the data in the domain layer is probably pretty obvious how you would test, but like the UI layer, like essentially it's updating state, and then you can test if that updating the state properly does the things you expect in the UI. But those are more integration tests, probably because compose, and that's actually dealing with the UI. And then, in your VM, there should be no business logic, allegedly. So like, yeah, I think it's all, Darren's actually the one who's doing the main part of this investigation at my job. He did the first page of compose, and he's investigating unit testing right now. I think it was all built with unit testing in mind. Just got to make sure you're architecting it. It's probably difficult to figure out how to architecture it as optimal as possible for unit testing, but it's definitely possible, and they kept it in mind. It's all over their docs on testing.
Yeah, so a good part of it is just follows the patterns of the previous UI toolkit. So Swift or Compose, which is comparable to Swift UI, is very similar to, as Josh mentioned, like Flutter as API as well. But for the most part, you're still using, actually you can use the same exact view model and classes and types. So all of that testing maintains, you can maintain all those same testing patterns. There is a new API for testing compose views because the views are rendered differently by the runtime. And so you can't use the previous framework, which was like Espresso. There's a new framework that works more of like an accessibility framework. But you can use the same tooling like devices and emulators, but the testing library is different, and the API for testing the UI itself is different. But you can do the same things like mock out your view model in that new, the cool part about Compose is all your UI is generated from functions like that are annotated with Compose. So you can pass in the dependencies or the state at any kind of like unit you want to make those composable functions. So that could be a really big composable function that does your whole screen, or a bunch of little ones that you build into a bigger screen, or whatever you want to do. And you can test those in isolation. But for the most part, that's the only thing that's changed. Everything below that can stay the same. You can still use clean architecture with this and test using those same patterns.
Yeah, and also like that's the slide on state hoisting is the reason why you do that is for testability and also reusability. So like essentially make it so your composable functions are simple to test, and like don't, like, let's say your composable function optimally wouldn't take a whole view model, so you have to mock the whole view model. You just kind of say, hey, you clicked on a button, fire that event up the chain, and receive the state of that. I guess there's no state with a button, but like hypothetically there's a state in some example.
A text field, for example. So this is actually one of the more controversial design decisions in Swift UI, right, is the binding, because the binding is not a very good functional programming kind of thing, but it lets you get rid of this state hoisting problem. Because in Swift UI, you can actually borrow the state from somebody else by using a binding. which makes it bidirectional. So you have a single source of truth, and then somebody else can borrow the state. So for example, you have a text field, you can lend the value of your string to the text field, and then whenever the text field updates, then you update automatically, which is kind of gross because it's both an input and an output, but it does let you write a lot less code.
Yeah, I mean, I don't know. That's something to think about for sure. Yeah, seems like you could maybe get in trouble there, but yeah, I don't like, you can borrow state from higher up in the tree without passing it down using what's called a local content provider. That basically allows you to get access to higher level state without passing it down. But I don't think you can update the state using that. It's kind of one way, but
yeah, I think that if Android really wanted to, they could copy the iOS implementation, because a binding in iOS is just a property wrapper that has a getter and a setter. And you should be able to do the same thing with the property delegates in Kotlin. I think they just decided not to do it that way.
Yeah, I think they probably didn't do it like that way on purpose. But I guess we'll see if they ever add it. Or maybe it's already there, we just don't know.
like in Flutter, you can kind of do the same thing. Like you can set state from anywhere. It does make things a little, like imagine debugging things where you can set the state of the entire app from anywhere in the entire app. Like it does make, like that's why I said it's an interesting capability. It definitely makes some things easier, but some things are probably gonna happen that you're gonna be like, well, why is this happening? It's like, oh, well, because someone put this here, some like widget somewhere else on another screen or whatever. Maybe it's somewhere in that screen that's modifying something at a higher level. I don't have a strong opinion on it, but you do have to probably consider that can happen.
Hopefully in a month we'll be a lot more confident in our compose. We'll be learning a lot in this next month, because we're kind of creating this architecture of how we want to do it, and we're going to replicate it in the whole page. So then in a few months we'll have, I would say, 2/3 of our app in compose, and that'll be pretty exciting.
But like for TCA, I guess you don't have that problem though, right? Because you're just updating state from events, so you can always see whatever generates that event. I guess you can also in Xcode probably find like whatever accesses that property or that binding to, figure out what's updating it. Yeah, I don't know. We're still learning. I think based on everything I've seen, we haven't needed to update anything up the tree so far. We've been able to get away with maintaining state inside view models. And so is that a similar construct in SwiftUI, like binding a view model to a view and then subscribing to that state?
Yes, except that in SwiftUI, it's all done automatically because it's done through the protocols and the property wrappers, so you don't have to do as much manual binding work. There's a lot of magic going on under the hood to make it work, but it results in much more succinct code. And you can also borrow state from the view models as well, because the projected value of the view model is a wrapper that creates a binding to any published property. So you can directly borrow the state, for example, from a search field into the view model, and then it will pipe that into the view model. And then the view model has a published property, so it is a publisher's, like an observable, so you can actually subscribe to it and listen to all of the changes on the text field, for example, and then transform those into some other stream of events, like a network request or a database query or whatever, if you want to do like type as you search.
Yeah.
Like, don't you with SwiftUI have to interact with, like, basically have your struct implement an interface? Is that always, or a protocol in iOS?
It implements the view protocol, and the view protocol is only one function. It's body.
Yeah, I don't like it when like things force you to modify your models, force it to implement, like, because like if you think about it in a way that I'm like if I'm trying to do cut multi-platform and I'm going to automatically generate these structs, I'm going to have them automatically generate and then implement this interface, which maybe it's not the end of the world, but it's kind of like not a one-to-one translation if I ever want to get that out. It'd be interesting because we're going to probably use cut multi-platform at work, and it's going to be interesting to see how that plays with iOS land.
David, are you talking about views, or are you talking about like data structs?
I'm talking about, I think, data structs. Does data structs have to implement?
So we have this idea of an observable object, which is actually like a class, and it's still kind of like state binding or publish. But it just, I don't know, maybe Josh can talk about more of the inner workings of it. But yeah, we have these observable objects that we add, and those don't require any like specific function or something. It just comes with the did change publisher that kind of auto works with the at publisher annotation. But yeah, Josh, take over.
Will change. They say that they changed it from did change a long time ago. But
Yeah.
Do you want me to show you an example? I can show you really fast
Sure,
what
sure.
I'm talking about, just so you can see what the difference is. Okay, so here's an example that I did for my meetup, which is just a reactive search as you type kind of thing, right? So in SwiftUI, you write your view as a struct. So SwiftUI heavily leverages the type system, right? So in Android, you're using a function. In SwiftUI, you're actually using a struct. And it conforms to the view protocol. The view protocol has a single function, which is that you provide a body variable that returns some view, right? So within this, this is a view builder, which is a special kind of thing that lets you write a DSL. And that DSL is this basic like subset of Swift that lets you declaratively specify your interface. And this body function, you should really think of it as a function of stuff. And the stuff that is a function of is all of the property wrappers on the view, provided that they conform to dynamic property. And so I only have one function, which is, or one property wrapper rather, which is a state object, and that's my view model, right? And so that's the thing that I'm searching for. So you can see that if I go in here and I type as I search, then it goes out and makes a network request, and then it fills in all of the search results here, right? And so this is basically what the view looks like. To describe all of that, there's one main search view, and then there's another view that describes each cell in the return values. I think this is the Scryfall API, so these are just like magic cards. All right, so all of this code, right, that's what gets you all of the UI on the screen. And then the business logic is this state object, right? So this at state object is my view model. That's the business logic. And you look at the business logic, the view model is basically a function, right? So just like the view is a function, the business logic or the view model is also a function, but it is a function that transforms all of its inputs into some set of outputs. And here you can see that I've used @published, which is the special view model thing where any property that is published, when it changes, that's what the view is actually subscribing to on the state object, right? So this triggers the object will change publisher, and that's what causes your view to rebuild. So anytime you want your view model to update your view, you just emit a new value for some @published property, right? And then the thing that I was talking about is this search term here, which is the thing that I type in the search bar. That is actually a bidirectional property because it's a binding, right? I'm lending the source of truth of this search term to my view, and then the view is in turn lending it to the search bar, right? And so that's how the search bar gets its source of truth. And whenever the user types something in, the search bar automatically updates the source of truth, which is the search term. And then because the search term is a published property, this is actually my input, right? And the cards are my output. So you can see that conceptually what I'm doing is I'm transforming the search term into an array of cards. And I just do that with combine, right? So I'm debouncing it, remove the duplicates, transform it into a network request, switch to the most recent network request, map the result back into a card view model, switch it back to the main queue, and then assign it to cards. And then that's what triggers the whole thing to update. And this, believe it or not, is actually a single expression, right? So my whole view model and the whole reactive thing is a single expression, and that's it.
So the struct of card, it looks like doesn't need to be touched. Just the view model needs to have the at publish annotation to.
Yeah, so you only need to use a view model okay, I guess you could technically say that card view does have a view model, and that view model is the card, but it doesn't have a view model with dynamic behavior, right? So if and only if you have dynamic behavior that you cannot delegate to somebody else, then you use this at state object. This view model is just a plain old struct because the cards are immutable, right? They never change. And because there is no dynamic behavior, you don't need to be able to observe the view model. And so the view model is just a plain old struct. Any other questions?
I need to bounce, but thank you very much. That was great, Josh. I appreciate you guys letting me sit in. Thank you.
Nice to meet you.